Networking protocols. We're looking at TCP IP. Now, there's been a lot of networking protocols over the years. Now, Apple had Apple Talk, which was only marginally routable, really wasn't designed to go across the internet. Apple Talk wasn't used on the internet, but it could connect Apple networks to other Apple networks. It eventually faded in about the late 90s. Novell had IPX-SPX. It was popular until the late 90s, where Novell ditched it. Microsoft had NetBEUI, a local area networking protocol that was popular until about 1996, where Microsoft effectively ditched it. Everyone ditched every other protocol. They said, we don't need you any longer. There's this really old protocol out there that does a great job called TCP IP, Transmission Control Protocol over Internet Protocol. We can run TCP IP for reliability services over a routable protocol that can go anywhere in the world. TCP IP. It became the standard of everyone. Now, when we look at our addressing schemes used with our networks, we have something called a MAC address. It is a physical address that should be unchanging for that device. Every network device should have a MAC address. And it's a 48-bit unique address, or 6 hexadecimal pairs. And we'll see that on the next slide, I believe. Now, we also have IP, our logical addressing. And we've been using IPv4 for years, but now coming out of everywhere is IPv6. We're making a slow transition to it. We've got quite a bit of material here on IPv6, probably much more than the exam is going to have, but it'll help you for the future. And then there was other addressing by just using a character-based name. And things like NetBEUI used a host, well, used a NetBIOS name for recognizing a computer. Now, when we look at other character-based names, we're going to look at host names and DNS, but that's coming up a little bit further on. Now, the MAC address is also known as the physical address, adapter address, or Ethernet address. It's an unchanging, or should be an unchanging, unique value. It's expressed as 6 pairs of hexadecimal numbers, or 48 bits long, often separated by colons or hyphens. Okay. The address, the first 24 bits of those 48 bits contain the manufacturer's ID, or OUI, and the next 24 is the serial number from the manufacturer, a unique number to identify it. The MAC address should not change on the device. Now, you might notice the slide says it doesn't change, and I'm saying it shouldn't change. There are devices that allow you to clone another device's MAC address. There are some devices that allow their MAC addresses to be changed, but in general, the material is right. MAC addresses don't change. You know, there are exceptions to that, but MAC addresses are used on your local area network. All communication on your LAN is by MAC address. Even if you're talking to an IP address, it's going to resolve that IP address down to the MAC address and send communication on your LAN by MAC address. MAC address is used on your LAN. Now, IPv4, it's been the internet standard since 1981, and it served us well in that time. We're still using it for the most part. It's binary data, 2 states. You have on and off, 1 and 0 respectively. You have a byte, an octet, 8 bits. Now, when we talk about IPv4, we say it has 4 octets, 4 strings of 8 bits. So the IPv4 address is 32 bits long, divided into those 4 octets. So you see that beautiful number there, that 11001010, and so on? That's binary. And you might notice there's no dots. And there shouldn't be when it's in binary. An IP address written in binary is one contiguous 32-bit number. Well, that number can be converted into what's called dotted decimal notation, where we take it and we change it from binary. We take every 8 bits and turn that into decimal. Now, in the case of this slide, what we show in binary and what we show in decimal are not the same. Let's see, 192 plus 16 plus 2. Someone can do the math. 192 plus 18, 202, 210 and not 208. Oh, maybe that is it. No, it can't be because it ends in 15 at the end. So I know that's not it. It's not 56 at the end. So it's pretty close. Someone may have started out doing pretty good, but they're off a little bit. Okay. Now, it can uniquely identify up to 2 to the 32 power addresses. That sounds like a lot. Now, IP address is composed of two parts, a network ID and a host. No two computers on the same network can have the same host ID, but two computers on different networks could have the same host. So you have to have a unique host for each network. But between networks, you can have the same host number, but they're identified as belonging to a different network. And we have different IPv4 classes. We have Class A. Now, when we look at classes, we're looking at only the first octet to determine the class. In Class A, the first octet is 1 through 126. It's Class A. Now, in Class A, the first octet becomes the network. The next 3 octets are for the host. So it has a subnet mask of 255.0.0.0. Now, you may see CIDR notation at some point. In CIDR notation, they'll have the IP address slash something like 8, saying 8 bits are used for the subnet mask. Well, 255.0.0.0, that 255 is 8 bits, and the rest being hosts. So you might see something like 126.0.0.0 slash 8 to represent an address. The Class B is 128 through 191. Now, Class B uses the first 2 octets for the network and the first 2 octets for the network, last 2 octets for the host. Default subnet mask is 255.255.0.0, or a 16-bit mask, so slash 16 if you prefer. Class C is 192 through 223. First 3 octets belong to the network. The last octet is the host, and default mask is 255.255.255.0, or a 24-bit mask. You may be looking at this and going, those are just odd, strange numbers. And I don't blame you for thinking that. Bear in mind, the computer is working in binary. We look at that first octet. It's 8 bits long. Class A is going to begin with a 0. Class B is going to begin 1, 0. Class C is going to be 1, 1, 0. And that's how we can tell what class it is. It becomes obvious when you look at them in binary, but it's not clear when you look in decimal. Class D would be 1, 1, 1, 0. And that would be 224 to 239. That's used for multicast. There is no subnet mask that belongs to it. You can give everyone the same multicast address. When you send something to that address, everyone receives it. Now, Class E and sometimes also Class F, most books combine them together. The exam is probably going to have them combined together. It's 240 to 255 for research and experimental purposes. Someone said, is there anything we can do to make IPv4 nicer? Well, let's leave a little area for us to play with. Now you may be thinking, we have quite a bit of area, and we're running out of IP addresses. Bear in mind, when IPv4 became popular, they really didn't expect much more than 100 or a few hundred computers on the entire internet. They didn't see this as an issue. They didn't think that we'd ever run out. We didn't run out until the late 90s, and then we started doing tricks to fix it. And now, even those tricks are beginning to fail us, so we're moving to V6 quickly.